You do not need a dilution refrigerator in your garage. That sentence changed. Who gets to experiment with quantum computing? Cloud platforms queue your circuits on real hardware in real labs. You write the job. You wait in line. You get results back over the internet. In 2026, that is how most researchers, students, and enterprise pilots actually touch quantum processors. Not by buying chips, by renting time. Today we map the major portals, what each one is good for, and how to choose without wasting months on the wrong queue. IBM Quantum is the ecosystem most developers meet first. Qiskit is the open-source SDK. IBM Quantum Platform is the cloud portal. You build circuits in Python, push them to real superconducting processors, and pull histograms back. IBM publishes queue times, calibration data, and a growing set of utility-scale experiments. Strengths: huge tutorial library. Enterprise relationships, frequent hardware refreshes. Trade-offs: queues can be long on popular devices. Not every backend suits every algorithm. If you are learning or prototyping VQE and QAOA workflows, IBM is still the default front door. Amazon Braket plays a different game. One API, multiple hardware partners, IonQ trapped ions, Rigetti superconducting chips, Oxford quantum circuits. Braket is the marketplace model. You stay inside AWS workflows. S3 for data, IAM for access. Hybrid jobs that burst classical compute beside quantum tasks. Strengths: backend choice without rebuilding your entire stack. Clean enterprise billing. Trade-offs: you live in AWS land. Pricing surprises if you ignore idle classical resources. Braket wins when your team already runs on AWS and wants hardware optionality. Microsoft Azure Quantum targets teams embedded in Azure and the Microsoft developer stack. You get Quantinuum access, Azure credits, and integration with classical HPC resources. Good for enterprises already standardized on Microsoft tooling. Google Quantum AI pushes its own superconducting hardware and research stack. Circ for circuits, experiments that showcase error correction progress. Access is more curated than IBM's OpenQ. Strength for Google, cutting-edge demos tied to published papers. Strength for Azure, procurement-friendly paths for large organizations. Pick based on whose cloud you already trust. Here is the decision map. Learning and coursework. IBM Quantum first. Multi-Backend enterprise pilots on AWS. Braket. Microsoft Shop chemistry and optimization trials. Azure Quantum. Tracking fault tolerance research demos. Google Quantum AI. Neutral atoms and specialty hardware. Smaller portals like Chuera through Braket or direct partnerships. One mistake: choosing a portal because the logo is famous. Match portal to algorithm, queue depth, and your existing cloud bill. Cloud Quantum is not free in practice. Research credits exist. Students get promotions. Enterprises sign contracts. But queues matter as much as price. A cheap backend with a 6-hour wait kills iteration speed. Watch queue depth, shot limits, and reset windows. Read the billing unit. Per shot, per task, per minute of quantum processing time. Classical pre-processing often costs more than the quantum line item. Budget both. The teams that win treat cloud quantum like a lab instrument. Book time. Prepare circuits offline. Analyze results batch by batch. Your move. Pick one portal aligned with your cloud stack. Run a Hello World circuit this week, not next quarter. This week. Measure queue time, fidelity of results, and how painful the SDK feels. That tells you more than any benchmark slide. Cloud access is the on-ramp. Fault-tolerant hardware is still the mountain. Tune in tomorrow. We cover quantum advantage, the benchmarks that actually matter, and when quantum beats classical